Welcome to technical session number 19. We're getting into TCP/IP protocols today. Talking a little bit more about the purpose and role of TCP/IP in the internet or private networks. So we're going to start distinguishing between a private network and the actual internet itself. We're going to be explaining some characteristics and properties of TCP/IP and explain some common TCP and UDP ports, protocols, and their purpose. Simple, right? We'll be getting into BSMs for this particular one, adaptability. Things are always changing. New information is always coming out. New things are constantly being thrown at us, and we need to be able to move, adjust, and adapt to those various scenarios so that we can continue to be successful, grow, develop, and learn as IT professionals. And the mindset, we also want to keep in mind personal responsibility. You know, we make sure we do what we're supposed to do, what we need to do. We're getting our work done. We're putting in the time. If we say we're going to do something, we follow through with that. Good way to keep up with that, especially in here with studies, have an accountability buddy. You know, link up with somebody, say, hey, I'm falling behind. I need someone to kind of hold me to account if I don't get my reading in at night, if I don't get my Coursera done, if I don't get my labs done. It's like we said, you know, if you do the New Year's resolution, like I'm going to go to the gym every day. Well, if it's just you, it's easy to be like, nah, I'll just start tomorrow. Or nah, I'll just go home tonight. And then eventually you stop going altogether. But if there's somebody there waiting and depending on you to be there, that changes the game entirely. You start showing up more. You start, you know, getting there and actually putting the work in. And then you can develop those habits, rituals, and routines that will carry you forward. All right, overview, TCP/IP. What exactly is a protocol? In a very, very basic sense, it's essentially a set of rules that are agreed upon when communicating electronically. It's a very concise way to break it down. That's all it is. Set of rules both sides are agreeing on when you're communicating electronically. And depending on the protocol you use, you're going to be using different rules. All right, TCP/IP, we've heard that word thrown around a little bit. What exactly is that? That is Transmission Control Protocol, Internet Protocol, which is essentially a collection or group of protocols used to communicate over the modern networks, essentially, including the internet. And then next term we need to be aware of is host. What is a host? That is a machine or interface that participates in said network, whether it be a client or a server. It is essentially a node or a computer or machine, what have you, that is on the network itself. Any questions?
Does this include also router? Gateway router?
I don't think, well, that would be an internet network device. I don't believe they would consider that a host.
All right, thanks.
Mm-hmm. All right, protocols. So if I am going to communicate with, say, Casey, I'm going to be sending a message to her and I need her to respond to me and let me know what's going on. I'm not going to type that message in Cyrillic like Google does. You know, it needs to come to her in a language in which she is going to be anticipating and understanding. So that's what these protocols are for. So if I'm going to be communicating, say, with a web server, I cannot be using protocols, say, for LDAP, you know, or email. They're not going to be using the same language, so to speak, or the same communication rules. So of these sets of rules, One of the most popular is TCP/IP, which is that transmission control protocol / internet protocol. Not necessarily because it's the best, it's because it is partially the most adopted. It's what's used for the majority of the internet. It's kind of like the VHS Betamax argument or the HD DVD versus Blu-ray argument. As these technologies arise, it's not necessarily the superior technology that wins, it's the one that is adopted by the most amount of people. So same thing with TCP/IP. Other versions that were out there, there was the IPS, IPX, SPX. There was the AppleTalk, NetBIOS, and NetBUI. So these were other ones that were out there. Do you need to be intimately familiar with all of these? No, just know that they existed and that they would come in under network protocols. Now, this one may seem familiar to you. So they break down these protocols into layers. There's a couple different ways they break these layers down. In Coursera, Google talked about a 5-layer model. Then there is this, which is considered the 4-layer Department of Defense model. And we'll show you again a 7-layer model. Basically, it's all the same stuff. It's just how they bunch it together. The two easiest ones to remember are the OSI and the Google, because they use the exact same ones all the way up, and then all that Google does is they combine. Oops, sorry. What am I doing?
Kelly, you just not used to having the hand yet.
I know, right? It's like everything's going haywire now. So Google combines the top 3 protocols and make that one solid protocol. And then the 4 lower ones, they still have those as the same name. Department of Defense clusters them together, like you have the network access protocol at the bottom, which is the combination of the physical and the network layer, or no, excuse me, physical and data link is the network layer. The network layer becomes the internet layer. Transport layer stays the same. And then the top 3 of the OSI become the application layer, same as the Google model, which is the session, protocol, and application. Yeah. And basically what it is there's different things that operate on each of these layers. Remember we were talking about the network devices where we said hub was a layer 1 device, and it basically uses just 1s and 0s. It shouts everything else. So that's your physical stuff. That's going to be your cabling. It's going to be your NIC. And the communication that happens on that level is binary. It's 1s and 0s. You go one layer above that, you start using frame relays, you start using MAC addresses, things like that. That gets you into your data link layer. And then you get up into the internet layer here. It is the network layer in the OSI and the Google model. That's when you start getting into ICMPs, you start getting into IP addresses, version 4 and version 6, which we'll talk about here in a minute. And it's just a way, if you're having issues with specific things, you can look and see which layer it's affecting, and it tells you how to troubleshoot it. That's basically what this is. It's just breaking things down on a protocol level at which layer they interact with the computer. So kind of how this would work is you would start up at the application layer. So like I want to send a message to a web server. I want to make a request of a web server. So that's on the application layer. It's going to work down through the layers. So I make the request in the application sense. It goes down to the operating system. The operating system breaks it down into, manageable chunks. It gets down to the network card. The network card breaks it up into packets and sends each individual packet over. It goes over to the other system, and then it has to put all that information back together, send it back up through the operating system, and talk to the web server. And then when the web server responds, it goes back through this process in reverse. I do have a video that breaks this down, how the internet packets are formed. and how each of the layers handle that information. Mike Myers has it. He does a really good job of breaking it down. So I'll show you guys that one a little bit later. And it makes a little bit more sense when you're talking with the layers and how the data gets broken down into smaller pieces and then reassembled as it comes back up through the layers. Questions on that right now? Again, you just need to know this from a 10,000-foot view. You do not need to be intimately familiar with it.
I think it's very difficult, Kelly. I don't know. I found it really difficult because at some point you have to subtract one, and then there's a router IP, and then there's a MAC IP address, all that stuff. When it comes to the quiz, it was really hard. I had to do it a
Yes.
few times, so I'm just gonna pay attention.
Well, that's fine. And then when I show you the Mike Myers video, he does a really good job of breaking it down by the chunks. And it's like different pieces of the network need different types of information. And we'll talk about that a little bit as well. When we start talking about public versus private addresses and how that's, being utilized. So that might clear things up a little bit for you, Cynthia.
I will also be drawing this out for anybody that wants to see it like displayed in a more like more image based way. I actually like drawing this out with the port numbers and stuff like that. It's actually really fun.
Okay, nice. I'd be interested in seeing that.
Yeah, it's really cool.
Okay, excellent. All right, so typically when you're talking about the layers, you start numbering them from the bottom up. So you start at the physical layer, that's layer 1, and then you go all the way up to application, which is layer 7 or 5, depending on which model you're using, or 4 if it's DoD. But we'll be talking about different protocols and like how they interact a little bit more as we go along. So, all right, HTTP. This is your internet web address protocol. We'll give you the port numbers and stuff on this as we go. This protocol essentially governs the way a web server and a client will interact. So like when you go to Google and say, hey, I want to look up, hey, Google, give me hamburger, restaurants near me. And it'll give you a list of them based off of your location and all that fun stuff. Well, the HTTP protocol is what governs how that communication is going to take place. Format of the information, how it's transmitted, all that fun stuff, what ports you're using, everything. Now we're going to talk about transmission control protocol. Remember how we talk about TCP/IP, transmission control protocol, internet protocol? Well, you have transmission control protocol, which is managing the individual conversations that you are having. So think of your computer when it's interacting with another computer on the network, it's having a conversation. And as we don't want to send a huge chunk of information at one time, because if one little piece goes wrong, we have to send it all again. We tend to break things down into much smaller chunks. And we send those packets out a piece at a time, and we use a numbering system and stuff to let the other end know how this puzzle needs to be reassembled so that we can look at that information.
Fragmentation.
Yeah. So yeah, it breaks it like it takes a picture, breaks it down into 1,000 pieces, sends those 1,000 pieces through the internet. When it gets to the other side, it says, okay, this is piece 1 of 1,000, 2 of 1,000, 3 of 1,000. And then if it goes through and one of them's damaged, and say, hey, I didn't get packet number 216. And then it'll resend that for you. So TCP does that. It maintains a two-way conversation, and it verifies that the information has been received. So it's basically, it's like, hey, I sent you 1,000 packets. Did you get everything? And then the receiving computer be like, yep, I got everything. Or nope, I need these packets resent. They never arrived. And so it's a two-way conversation. All right.
Are those the only protocols that are on those layers?
No,
No.
no, we're going to be talking more about them.
Okay.
So we'll be getting more into it. And HTTP isn't really a layer one. I don't know. Okay. This isn't layer 1 and 2. This is page 1 of 2. If
Yeah.
that makes sense. So we're going to be talking a little bit more about the layers. All right. Next, IP or Internet Protocol. And this is responsible for basically taking those segments, encapsulating them into what are called packets, and then assigning them the appropriate address where each packet is supposed to go, like we were saying. And then it will deliver them across the best path. So it's not always a straight line, say, between me and y'all in New York. Because what if those lines become busy along the way? We have to find alternate routes to get there. So we may skip over to routers in Ohio and then come back to New York if I can't go a straight line up through the Carolinas or whatnot. So it's trying to find the best path or the most efficient path to get those packets to where they are supposed to be. And they use IP addresses for the most part to route those packets where they're supposed to go. All right. Network access protocols. Take the packets from the IP, format them to be transmitted over the media, essentially. The standards for the protocols are based upon the physical mediums, being that twisted pair, coaxial cable, Wi-Fi, fiber optic, what have you. And that's going to govern exactly how those signals are going to need to be sent out. And once they're done, they send them out and they have basically instructions on how they're supposed to be interpreted on the other end, basically notifying this is packet 1 of 20, 2 of 23, or 24 of 20. So it knows how to assemble those packets in order to give you the information you are needing. All right, let's dive into this a little bit. IP addresses. So there are 2 different types of IP addresses currently in widespread use. You have IP version 4, which is probably going to be the one most of y'all are most familiar with. And then you're going to have IP version 6, which is the one that is coming into common usage right now. So IP version 4, I think there was only a couple billion addresses. They thought this would be enough back in the, I guess, the 80s when they came up with this protocol. But around 1996, they were running out of addresses. So all the way back in the 90s, and that was before massive widespread use of the internet. They were running out of addresses. They had no way. They were trying to figure out a way to get around this. How do we deal with it? And so they started trying to move to the next one, because when they first came in, they're like, there's no way there's going to be 2 billion computers or network devices on the planet. Come on. They're too expensive. Computers take up an entire room, all that kind of fun stuff. Well, once they started realizing the error of their mistake, they had to find a way to bridge that gap so that they could continue to operate off that IP version 4 while putting in place the IP version 6 protocols. So IP version 6, the way the address is set up is it's using hexadecimal format, which we talked about last week, where you have the numbers and letters. What's the highest letter we can go to?
E?
Not E.
F.
F.
Gilly.
F. So numerically, what number is F?
16.
Not quite. 15.
15.
15. Remember, 0 takes up a space. So numerically, it's 15. So we can count from 0 to 15. And there are 8 groups of 4 hexadecimal characters that make up an IP version 6 address. And the amount of possible addresses that you have is like 340 undecillion numbers. That's 340 with like 32 zeros behind it. That's more addresses than there are grains of sand on the planet. And interestingly, the way things are growing and developing and networking and all that stuff, we think that may be good. And then in 15, 20 years, we may quickly be running out of those too. Who knows? But that gives us a lot of breathing room. But there are still some protocols that still operate off of the old IP version 4. Most private addresses do as well. And then when you get out into public networks, they're starting more and more to talk in this IP version 6, but we'll talk a little bit more about those as we go along. So IP version 4, 32-bit address that's broken up into 4 blocks. So you have 4 groups. Each group is actually represented in binary by 8 bits or a byte. But they often will mention it as called a octet. An octet and a byte are the exact same thing. It's 8 bits. You will see the addresses here like this. So 4 groups of numbers. They can range anywhere from 0 to 255. Why don't we go to 256 or 257?
Zero takes up.
Zero counts as a
Zero,
space.
there you go. 0 takes up a space, and with 8 bits, the highest number we can count to is 255 when we include 0. Excellent. So the computer does not see it this way. The computer literally sees it as 1s and 0s. It's just translated into this format because it's easier for us to manipulate and work with. So with this, we have 4 billion unique addresses. And these addresses are handed out by what is called the IANA or IANA, which is the Internet Assigned Numbers Authority. So if you're getting a public address, you need to go to this group, request a number, pay the fee or whatever, and they will give you that number. And they keep track of all the IP addresses and who owns them. When you move into IP version 6, it's a little different. Like we said, you got a little bit more complicated with regards to the addresses. You got letters, you got numbers. Sometimes you got this funny little double colon thing going on here. They use a compression mechanism to kind of make it so it's easier to write because nobody wants to write out all those letters and numbers every single time. And it's 128 bits versus 32 bits. So significantly more code to represent a IP address. Questions on this so far?
I should also mention that when you see the colon, it could be a set of 8 zeros or 4 zeros.
Yes, we will get into that. So excellent. Good preview there, Ramon. Yeah, we're going to be talking about that. When you see the double colons, it can only be used one time, and then we'll talk about what it means. So excellent. All right. So because we were running out of addresses, we had to start distinguishing our private and our public. Basically, what's used on our intranet inside of our organization and the internet outside. But we also need to identify how to get these IP addresses to where they need to be. So that address that you have, get it right here.
Haley, that's nice. Can we do that too on our slides? Like to make notes on the side like that?
So do what?
Can we also do that? I'm saying that function that you're doing on the side there, it looks like it helps. Can we do that as well with our slides?
With the student-paced ones, I believe you can make notes on them each slide as well.
That would be
But
nice.
if you try doing it on the Nearpod, you're going to be annotating onto everybody's screen.
Oh, okay. All right.
So just be cautious with that one. All right, so we need to break up these set of numbers into smaller chunks. So there is 2 bits or 2 chunks to the IP address. 1 second. you have the network part of the address and you have the host part of the address. So the network would be the first chunk of it, however what it is, and it's not necessarily going to be 2-bit, 2 octets. And then the last half of it is going to be the host. So first we need to identify what network the computer's on, and then identify which computer is talking on that network. So when they're saying subnet mask, that's exactly what they're talking about. So first I need to identify the network, and then I need to identify the host. That's like me saying first, I need to identify what city you live in. So if you live in Manhattan, so I got to get to Manhattan first, and then I need to know your address inside Manhattan. So first, get to the network, second, the host. Now, when this comes across, how it is transmitted to the computer, what the computer sees would be so the subnet mask, when it's transmitted to the computer, is just a series of ones, which identifies how much of that IP address is part of the network, and then a series of zeros, which tells the routing system how much of the IP is the host. So it sends a series of ones followed by a series of zeros. That's what the subnet mask looks like to the computer. And then after that, they'll send your IP address, and it goes, okay, first 2 groups are network. So I know which network to send it to. And then once it gets to the network, the last 2 are for that computer that's on that network, or to the city, and then to the proper address in that city. Does this make sense? So that's what they mean by a series of contiguous ones. So a series of ones and then a series of zeros. So that's just all that is basically just telling the routing computer, this is what identifies the network. This is what identifies the host. Now, so the subnet mask, the computer sees it this way. There's 2 ways in which you will see it. So likely you will see it as, let me write this down here again, for this particular one, 255.255.0.0. So 255, how do we get that number? We turn on all 8 bits, right? Do you remember that? So we turn on all 8 bits in the binary, and the number we get is 255. That's the highest number we can achieve. So basically they summarize this right here. So it's 255, which is all 8 bits on in that first octet. 255, again, all 8 bits in the second octet on. 0, 0, all zeros for the rest of it. So this is how you would see a subnet mask. The other way you may see it, notated, has anybody seen it written this way?
Yeah, they had it before in Coursera.
Okay, does it now make sense why they did that?
Yeah,
little
because
bit?
something about you can't assign 255 or 0, it always goes to the router or something also.
Yeah, 255 is your broadcast address.
Yeah.
And 0 is your router address, yes. All right, so the other way you may see this exact same subnet would be /16. So why does it say /16? Because there's 16 ones turned on right there. 8 for the first octet, 8 for the second octet. So you get 16 bits for your binary. That's where for your subnet mask, that is where that number comes from. Does that make sense?
So anytime 255 shows up, that's what that means?
When you see 255, like when they say subnet mask and they start doing 255, 255.0.0, what they're saying right here in this one is they're identifying this as a class B network.
Okay.
So class B has 2 octets full.
So
Class
C
A
would be
only has
3.
1. Yeah, and C would be 3 octets full.
Gotcha.
So a class A would be 255.0.0.0 or a /8. And then a class C would be 255.255.255.0 or anybody want to give a guess on the slash notation?
24.
There you go. Nice, Artez. /24. So that's a class C. So what does all this mean? Why do we use A, B, and C? Why are we using these different sets of numbers and all that stuff? Does it make sense? I mean, why on earth would we choose to overcomplicate things and use this A, B, and C terminology? So this kind of breaks it down for you here a little bit. Why we use the different classifications is there's different size networks. Would I use the same network for Manhattan that I would for Wilkes-Barre, Georgia? No, there's 10 million people living in Manhattan. There's probably 100,000 living in Wilkes-Barre. So we have different size networks, so different size classes need to be used for those so that we don't waste IP addresses, right? So the absolute largest ones you can use are class A's. That gives you the most addresses you can possibly get. I think it's like 10 million addresses or something like that per class A. You know, this is going to be for government organizations, very large companies like Google, you know, somebody that's going to use up tens of thousands or millions of addresses. Comcast uses it. If you have a Comcast router, likely your IP address starts with 10. It'd be 10 dot, you know, something, not something, not something. Because it's a class A network. For the purposes of the A plus, they focus primarily around A, B, and C networks. I would memorize the value in the first octet. A class A goes from 1 to 126. If you see that in the first octet of an IP address, that is a class A. Anybody know why we don't say 127?
Because of the 0.
No, not because of the 0.
No,
It's a loopback address.
There we go. It's the loopback address. We haven't really talked about that. We will here in a minute. So the loopback address in IP form is 127.0.0.1 or whatever. Or basically it's anything in that 127 range. And basically, remember when we said the loopback plug is that little physical plug that you plugged in and it took your outputs and put them into your inputs. And basically the only thing that tool did was check to see if your NIC was functioning. If you saw the lights come on, you knew your NIC was functioning, you can unplug the loopback, you're good to go. This is a software way to do that exact same task. It's using that loopback address. But we'll talk about that here in a minute. Yes, George.
So that 127 loopback address is the same for class A, B, and C, and D? And E?
Yes.
Okay,
Yes.
cool.
So that is the same. But that number has been isolated. So if we remember when we were setting up our binary where it was like 1, 2, 4, 8, 16, 32, 64, 128. So if we turned on that last bit, that was 128, right? So class A has the first, it's all the addresses until you turn on that first bit. So it goes all the way up to 127, because once we turn on that other bit, we've turned on that bit, and now we're in class B.
Kelly, real quick.
Yo.
On Coursera, it says the range is 0 to 127.
Yes, but we've isolated 127 for loopback, so we've taken that out of the mix. That's why class A is 1 to 126. But they've set aside the addresses for 127 to be strictly for loopback.
Oh, got it.
We're just overviewing it right now. Don't expect to be an expert on it yet.
All right, one more thing. So every time, I think that's what George said. So every time we talk about, every time we you said setting it back for loop back.
Mm-hmm.
So it's gonna take away one value because even for the class B, I have 128 to 191. Oh
Yes,
so,
because
okay.
that's where the next bit is turned on, right?
Yes.
Does that make sense?
So if
Yeah,
I'm understanding correctly,
I'm here.
127 still exists as an address. They're just taking it out and using it for all the classes to check it. Like if they needs that software, or I'm sorry, that
Just
address.
I'm
Yeah.
in 127 for that one.
Yes.
Mhm.
So you can check and see if your NIC is working. It's just a quick way to check it.
All right. Thank you.
So the second bit, which is 64, right? So that's 64. And so 128 to 191 gives us our class Bs. And that's notated like class A, 1 to 126, that gives us 255. And then .0, that's our subnet classful mask. This is a class A, 255.0.0.0, or a /8. Those are the two ways that you would notate it for subnet mask. Next, class B, 128 to 191 range. The way it would be classified or shown on your subnet mask is 255.255.0.0 or /24. And then class C goes from 192 to 223. When I show you the program anding, this will make more sense. I'm going to show you that program here in a little bit, and I'm going to give y'all a chance to take a copy of it and be able to mess around with it a little bit. And this will start to make more sense where the ranges are. And then class C goes 192 to 223. And the subnet notation for that is 255.255.255.0 or /24. And basically what that means is the first 3 octets is dedicated to the network address, letting me know which network we're talking to. Those first 3 octets tell me which network. Just that last byte tells me which host on that network. So who wants to give me a guess as to how many hosts we can have on a class C network? Because we can only use that last
155.
Is it 255.
255 essentially, yeah. But I mean, when you get a little bit more in, they actually subtract 2 from that, one for the broadcast, one for the router. But so 255 would be the highest we could go, right? So that would be like mid-sized companies, what have you, but not a very big network overall, right? Yes, Artez.
All right, so you see how it's for the mask is /8 /16 /24. Is that the same as like so class A uses 8 bits like that, or class B uses 6?
That's absolutely it. So class A uses this 255 or 8 bits to identify the network. And then the last 3 are left to identify the host on that network. And A, B, and C are the big ones you need to worry about. D and E, you kind of need to remember that just what they're used for. D is for multicast networks. And then E is for experimental use, so colleges, military, stuff like that. Right? You can kind of visualize it a little bit better with this one. So class A, B, and C. For class A networks, there's only 126 class A networks. That's it. So to be very selective who gets these networks, right? You got to be pretty big organization because the number of hosts that you have, 16,777,214. Do I need to memorize that? No, but just know that it's a big number. It's generally in the 16 million range, what have you. Tens of millions. And then there's a very few amount of those networks out there. Class B, you have 16,000 of these networks and 65,000 computers on each of those networks. And then lastly, Class C, you have 2 million of those networks, but only 254 computers on each network, right? The way I've always thought about this, the way that it always clicks with me is I think of it in terms of cities. Mega cities, like big, major urban centers, New York, LA, Chicago, Atlanta. How many of those are there? Not many, right? So those are going to be your Class A's. Class B's are going to be your middle to small size cities, your Indianapolis, like Akron, Ohio, Jacksonville, things like that. Those would be your mid-tier ones. And then your Class C's, that's going to be like Quincy, Florida, Perry, New York, some small town that doesn't have a lot of people in it, but there's tons of those small towns, not many of these major metro areas, right?
Mm-hmm.
And so it's easy for me to find those major metro areas because there's not many of them. So I can say, okay, I need to send a packet to New York. So New York would be number 10 or whatever. So it goes to New York, but there's a ton of people living in New York. So I have to be very specific on the address that I'm using in New York. So it's going to need a lot more information for me to identify where Donnie lives in New York. Versus I'm going to Perry, New York, population 200 people, but there's, a couple million cities that are tiny like that. So I need a lot of information to get me to that tiny little city. But once I get in there, it's pretty easy to pick up where David lives. Does this make sense?
Mm-hmm.
All right. What's your
so
quote?
much? So much.
So what would be a /26 prefix notation? Is that Class D?
That's where we're going to be getting into this afternoon. That is CIDR subnetting, my friend.
So
Oh, no.
yes or no?
So what? No,
So
it's not a Class D. It's still in a Class C, but we will be talking about it this afternoon. So that is
okay.
CIDR. And that's breaking up some of these networks into smaller and smaller chunks. And that is what CIDR
Gotcha.
subnetting is. So we will be
I
talking,
remember
that is our
seeing that
afternoon.
on the lab, and I was like, what is that?
That was why I asked you to skip the lab.
I know, I didn't listen. I should have listened.
So that was why I asked you to skip the lab, because we're going to talk about this afternoon, and that'll make more sense after we get into it.
All right, great.
Madison.
Yes, I'm still having a disconnect with the how the computer sees it with the ones and the zeros. Like, I'm not getting that part just quite.
Okay, so it's kind of like a key to, to translate something, So the first thing that gets sent across the network when I'm routing something is going to be that subnet mask, because they need to be able to look at that address and be able to know where it's supposed to go. So let me write out another IP address here.
Madison, do you remember when you did binary?
Yeah, but when I'm putting it in, it's not computing the same. Like 192 is not coming out to 8 ones. 168 is not coming out to 8 ones.
If you 255 should be coming up to 8 ones, and the 80, it's because you're breaking up the it's basically the binary chart, how you have 128 to the value of 1. Each of those would be one set of the information, or one thing that you're turning on or off, like what Kelly is doing right there. What you see at the top is the IP address, and what you see afterwards would be like the network or where you're going on it. So if you were to say break that into like the notation we would use, that would be 255, 255, 00, 255, 000. The only reason why the computer sees it in the 0 sense is because the computer sees it in binary.
Right, but okay, so can you break down 192 to binary, that part? That's what I'm trying to
That's
get.
the part where that's the IP address. That's not the subnet mask.
Yeah. This is the IP address. Basically, this is your city and address where we're going, right? The
So we would
subnet
never
mask.
have,
What?
oh, sorry. I was gonna say, so we would never have to break down the 192 to the ones, like we wouldn't have to try to figure it out how the computer sees it?
Not necessarily for the A plus. I mean, but you need to understand where this stuff is coming from.
Only the subnet mask we're focused on right now, Madison.
Yeah, that's all we're worried about. So it basically, if I sent you an address, and this is the address I sent you, then you would need to know, how do I get to what city and what computer to talk to, right? Like, you ever looked at a phone number from an international phone and it's just a series and it makes no sense, but like when you're in the US, it makes sense because you have area code and then phone number, right? But because we're here, we know how to break down those numbers. So when I'm sending information to a computer, if I'm looking at this, depending on what type of subnet mask, it would be totally different. So like I may, if it was a class B, which is this one right here, which is 255.255.0.0, that tells me the first, give me my pen. Here we go. It tells me my first to here is the city I live in, the network. So this tells me to go to Dayton, Ohio. And then the second address tells me what city in Dayton. And that's if I'm using this subnet mask here that it tells it. What would happen if I sent it a subnet mask A and it essentially is using this first one here as the network now, and then the bottom one here as the address. And all of a sudden now the packet gets routed to Miami rather than Dayton because it's thinking only the first piece right here is the network versus this last, the first two being network and the last two being that host. Does that make a little bit more sense? That's why we use a subnet mask.
Not for me, but I will follow up with you, Kelly, later. Thank you.
Okay, I mean, we'll talk, we'll get into the binary portion of it a little bit. But when you see 255, 255, when they're writing out the subnet 0.0, that's how it relates to this. Because in binary, 255 is 8 ones.
I get that.
255 is 8 ones, and then 0.0. Yeah, there's a question in chat on that one though.
I got that.
So.
All right.
All right.
I feel
Kelly,
like I'm always there.
sorry.
Let me get Amaya, and then I will get to you, Cynthia, and then Nassim. All right. Does that answer your question a little bit there, Madison? We are going to elaborate on this a little bit more as we go. All right. Got it. Amaya, Amaya.
On your example, when we see this IP address, it starts with 192, and it's on class C.
That is a class C private address. I'm just putting a random number up there just to kind of use it as an example. That's all.
So it is okay. So it should be 25 to 225, 255, 255, 255, and 0, right?
Yes, that would be a class C subnet. Exactly.
Okay.
Make sense? A little bit?
Yes.
Okay. All right. Cynthia.
Kelly, I feel like the way you simplify it, I'm getting it, okay? And
Okay.
I don't want to confuse myself. Tell me if I have to stop and pay attention, because my question is, So it starts at, let's say it started 192.168.15128, right? And each time it hops from computer A to computer B, there's a router there. And then from computer B to computer C, there's a router there. So each time it hops, I think you subtract 1. And then when it finally gets there to collect the message, and then it's 0. And then when it comes back with a different IP. But if I'm confusing myself, I'm just gonna wait and
you're adding another protocol in, so you're overcomplicating it a little bit. You're getting into what's called TTL, or time to live. And so when a packet gets routed through different routers, it basically says, I'm gonna allow 8 hops. And then the message will drop. And so each router it passes through, the one on the edge of your network, and then every router after that, it drops one of those hops. So it's like hop 1, hop 2, hop 3, hop 4. And when it gets to hop 8, if it hasn't reached destination, it drops, because they don't want packets just randomly roaming around the internet, endlessly trying to find their destination. It clogs up the internet. So they'll basically say you have 8 chances to get there, or 8 hops to get there. If you can't get there in 8, we have to find a better path. But we haven't gotten there yet.
Would that be when you get the message say fail to send? Is that like a notification that your package dropped?
Yeah, a package drop. Not failed to send, that'd be you not being able to send it, but it would be a drop packet. Yeah. And if it does that multiple times and it keeps dropping, then it'll error out the message.
So the hopping is trying to find the right address, right? The hopping around.
Correct. Because there's there's more than one road on the highway that I can take to get from here to New York, right? I don't just have to go up 95. I can go up A1A. I could take small back roads all the way up through there. So there's a multitude of ways I can go. The same works for the internet. There's no one path you have to take. And so they're going to try to take one that has the least traffic, that's the most efficient, and work around any bottlenecks that they find. The internet is pretty brilliant in that sense. But if it is unable to in an efficient manner, it just drops the packet. So if like I end up in Denver, Colorado, and I'm trying to go to New York, there's a problem. I'm not just going to keep driving around the Midwest hoping eventually I'll run into Manhattan. At a certain point they drop and then they resend the information.
Thank you, Kelly. This is very simplified. Thank you.
No problem. Nassim.
I want to ask about what we said before about the IP address. So without the subnet mask, the address could be different addresses, could go different places.
Yeah, well, the same address could go to multiple places without the subnet mask, because it doesn't know what is network and what is host.
Okay.
That's a wonderful point. Yes. So if I think the first 3 are my host address, then I'm going to go to a totally different network than if it's just the first one. The subnet mask allows me to identify the networks easier. Does that make sense, Nassim?
Yes, thanks.
No problem.
You should teach at Coursera Google. You do it much better.
Technically, that's what I'm doing here.
No, but Coursera, for example, Coursera started from the physical level, and then the data link, and then
yeah. I mean, we're gonna look at that a little. Yeah, we're gonna look at it a little bit more. Like I said, I do have a good video from Mike Myers that gets into that, and he explains it beautifully, like way better than I ever could. And he's kind of a goofy individual, so it kind of helps it stick a little better. So, but we'll see that video here in a little bit, probably after lunch. I'll show it to you. Cool. Yes, Babukar.
Yeah, I'm just trying to make sure my calculations are right for getting the assignable Class A IP address, 16,777,214. Is it 2 to the power 24 minus
I believe
2,
that is,
or is just 2 to the power 24?
I think it's 2 to the power 24.
Do you have minus 2 to get the 214, or
I can't remember. I can work it out and see. I don't know if they actually did the subtraction of the 2 here.
Okay.
So.
All right, cool. Thanks.
Mm-hmm. All right. So any other questions? I know it seems kind of
There's a equation of how to get the that number. It's I don't understand it, but I wrote it down. It's h equals 2 to the 8th power minus 2.
Yeah, basically that's what Babukar was talking about.
Yeah, I don't
Yeah,
understand
that's
it, but I wrote it down. That I knew that was important somehow, but don't ask me how they got that equation.
Gotcha. All right. So let me put this in here real quick. This is what we call anding. Oh. Did I stop sharing?
Yeah, you stop sharing.
There we go.
There we go.
All right, so this is anding, and this essentially allows you to create IPs, and you can kind of mess around with this a little bit. I will drop a link to this in chat. Make a copy for yourself. Please don't mess around with this one because this is a master copy if you don't want to have to recreate it. So it shows you your bitmap here. So you got that 1, 2, 4, 8, 16, 32, 64, 128. So it shows you, you know, the binaries, right? And then you can actually work through binary here. And so say I do like 1.0.0.1.0.1.1.1.1. And that one's messed up. I have to fix that one. Somebody's been playing with it. So I'll go down to this one here. So zero it out. So if we want to do a binary 1.0.1.1.0.0.1.1, it adds it all up for us and tells us it equals 179 based off of those binaries. So you want to practice your binary. This is a great tool to practice your binary with. So if you want to see if you can work through it and get to the correct one, this is a way you can do it, working through one bit at a time. It already has the little scale set up for you for your binary, and you can work through it. And then we can see real quick, if I turn on everything, 1, 1, 1, 1, 1, 1, 1, 1. I end up with 255. And that's where that subnet mask is, and that where all the ones come in, is it's everything turned on. So class A, it was 0 to 126, right? But then we have 127 as our loopback, but that's still considered a class A for the loopback. Basically what that means is if I turn on everything except that last bit, I get 127. So I can go from all zeros all the way up to 0, 1, 1, 1, 1, 1, 1, 1 as a class A network for my start, right? Now, if I turn this on, boom, I can go from my class B range starts at 128 all the way up to 191, which is everything but the second bit turned on. So class B is represented by the second bit in the octet. So that's where that range is coming from. I thought these were randomly selected when I came through A+, and it confused the heck out of me. I literally thought they were just pulling numbers out of thin air, like, yeah, let's just make the range here. And it made no sense to me until I got to Network Plus. I'm like, oh, okay, that clicks in place. I get it now. And then class B, class C, so that's turned on. We have class C starts at 192. So anything starting at 192 up to 223, which is the third bit. So it's everything up until we would turn that third bit on. So it's starting to become a little bit clearer, like there's a little bit of order to the chaos, essentially, like how they're laying this stuff out.
A little bit.
A little bit. Okay. I'm not anticipating y'all being experts. I'm not expecting you to be experts. I'm just trying to show you where this stuff is coming from. All right. So let me stop share on that real quick. I'm going to share that with you guys around lunchtime. I got to go back in and fix the spreadsheet on that real quick, but I will share it with you around lunchtime so you guys can mess around with it on your own as well. All right. All right, so we now need to kind of talk a little bit about public addresses versus private addresses. So remember, we briefly mentioned a little bit earlier that we were running out of IPs back in the late 90s. And we've been kind of playing off of these older networks since then, and the usage of computers has exploded. So we've had to start distinguishing basically a private address versus a public address. And it's kind of a way we can use addresses over and over and over again, but use fewer addresses on the main internet. So we talked about a little bit earlier, we get IANA, and then the IEEE assignments are used for public IPs. Your internet service provider, be that Comcast or Verizon or what have you, whoever you get your internet from, they would provide you with an IP address. And they're classified by the first octet like we were talking about. So 1 through 126, extremely large networks. 128 to 191 for medium-sized networks, 192 to 223 for very small networks because we only have about 255 on each network. 224 to 239 is for multicasting, that's class D. And then class E is 240 to 255, and that is for testing and research and stuff like that, R&D. So this is just kind of reiterating what we saw on the previous slide. All right, private. So these are chunks of addresses that are dedicated to being used on intranets. So inside of your home, inside of your network, and if you check your own IP, likely you have one that falls in these ranges. So when your router is routing traffic, interestingly enough, it uses one IP for you on the inside of your network, and then another IP that everybody sees on the outside. It uses this through a tool that is called Network Address Translation, or NAT. So my address might be 10.0.0.1 on the inside of my network. If I run a IP config or whatever, that's what my address shows up as. Now, over the internet, that address is not able to be routed. It's considered an IP, a private IP, and will not be allowed to route over public addresses. So my public address may be something like 15.12.32.17. And that's the public facing IP for my router. And what this allows is multiple people to use the same public address. So I might be at an organization, we have 10,000 people there, but only 2 actual IP addresses publicly. But we have hundreds or thousands internally being used. But when it hits the router removes your IP, puts its IP on there, sends it out. And then when it comes back, it takes off its IP, puts your IP back on it, and then sends it into the network. It's basically swapping the IPs, and that allows us to use certain IPs over and over and over again, even though we were running out of IPs back in the 90s. Do you need to know these IP ranges for Class A? There's 2 private ranges in Class B, and then Class C. Yes, write these down, commit them to memory. You do need to know this. I guarantee you, you will have a performance-based question around these numbers. Didn't you have that one, Rachel? I know I did. So you had that one too? Okay. So take a screenshot, whatever you need to do. Remember it. Make little flashcards, whatever, you know, what have you. Comes back up again, that 127.0.0.1. That is your loop back. That is just you testing your NIC, making sure that it works. And it doesn't have to be .0.0.1. It could be anything in the 127 range, as long as it starts with 127. It could be 127.255.15.12. That's still a loopback address. It's just the 127 range is your loopback range. If you pull up your IP on your computer and it says 0000, it means you do not have an assigned IP address at all. And then if you turn everything on, 255, 255, 255, 255, that is the broadcast address for TCP/IP. It's basically you're sending a message out to everybody.
So Kelly, if I'm getting this right, the address ranges for A, B, and C are the ones that are reserved, so nobody can have those unless you request it, or is that how it works from the IN?
No. These reserved addresses are the internal ranges you would use on your network. So like I have a router and the IANA gave me, let's just say, one IP. So I have one IP, I have 50 people working for me. So I only have one address. And so what I would do is my router would use that one address to communicate with everybody on the outside. But internally, I would use these 192 numbers. So I'd have 192.168.15.12 communicating with, you know, say Adriel on 192.168.32.15. So I have those addresses internally inside my network, but when I go outside my network on the internet, I have to use a public address. And that would be the address that was given to me by the IANA group.
Got it now. So you just have to memorize these. There's no like rhyme or reason why they picked those that range from 10 to 255, for example, on the top one. They just did, right? Is there like a reason why they picked that range?
I can't remember why, honestly. Obviously there is a reason. But I can't remember why they picked those ranges. But yeah, we do need to memorize those particular ranges.
Got it. Okay. Thank you.
If I remember why, I will explain it. I just can't remember right at the moment.
It's okay. I'll look it up later.
So, all right. So 127, we need to know. I'm sorry, who's speaking?
This Amma.
Yes,
what is the difference between the two class B IP range?
Just the ranges that they use. So like if you had a class B network, you could decide if you want to use 172 or 169.
Okay, but no difference in their service?
Nope, no difference in service.
Okay.
At least not that I'm aware of. But yeah, no difference in service. Okay, Cynthia, private and public keys, that's network plus all the way. That's talking about encryption. So yeah, we're not going to be getting into, we won't be getting into that.
I told them all over the place. I'm just gonna pay attention to get this together.
It's fine. It's fine. Yeah, when you're talking about private and public keys, you're talking about encrypting and decrypting transmissions. That's totally different. So we can talk about that a little bit when we get into security, but that is getting pretty far into the weeds for right now. All right. Yes, Madison.
So can two private networks have the same internal private address?
Yes, absolutely.
How does that work? And it doesn't.
Well,
press-
because they're not being routed over the public internet. So they're not interacting with each other. Only their public addresses would be interacting with each other. And then when the communications go inside the networks, do they use those private keys?
Two people can live in two different buildings, but live on the same 2C apartment.
There you go. That's a good one. I like that.
Yeah.
Thank you.
Did that make sense? What Adriel just said, Madison? All right,
Very
perfect.
much.
So I like your analogies, sir.
I had a lot of confusing moments with TCP/IP.
I got you. Nassim.
Yeah, I want to ask, does dynamic IP address and static IP address come in this subject, or nothing to do with this?
Yes, it does come in this subject. We're probably going to be talking about it in a few slides. So, excellent question. All right. So, remember again, 127 is our loopback. The software way to test our NIC, the 0000. We have an unassigned IP address. We have not been assigned one. And now, I know y'all would feel neglected if there was no quiz. And I know some of you are going to go, hey, can you drop the nearpod?
Don't make fun of us, Kelly. We always do need those extra slides in the chat.
I'm not trying to make fun. You need to stop and add sound so that I'm not the only one enjoying the music. I know y'all love it too. So. All right. Lots of penguins. We're about 19. How many people we got here today? About 36.
I don't know where I'd be if I missed today's class. This one's tough.
Probably sleeping
You would
comfortably.
be, nah. You'd be in a breakout room with me while I'm on my tablet drawing away. All right. Because this is like the funnest thing to explain analogy wise, because it's the easiest way. You just think of TCP/IP as like roads and destinations, everything. And once you get to the destination, apartment buildings, apartment numbers, and then people, it just becomes so easy when you think of it like that. Just
yeah.
That's a really good way to think about it.
That's cool.
All right. Here we go. And 255 and 0 to 0. What class is that? Flash 8. What class is that?
too fast. That's not fair, bro.
255.0.0.0. /16. Is that an A, B, or C? Nice. Last question, 285 to 255 to 255.0. Is that an A, B, or C?
What is that last answer? Jupiter and Venus? What is that?
It's astrology, man.
That's some
What does
astrology
that have to do with
nonsense.
Venus?
The fifth house.
on.
Oh my gosh. That's how you know he's really into astrology. He knows the houses.
Yeah, I have no idea what that is.
Astrology world.
All right.
Finally, I get a good freaking score on this.
All right. SK, Donnie, Ninjin, top 3. Very good. Maddie and Ramon rounding out the top 5. Nice work.
Where's my name at?
That's
Bro,
good.
Bro, I said, bro, it's all right, bro. They don't want us winning out here, bro. It's all
That's
right,
all right,
man.
bro. I know. It's sad though.
All right.
Pippa.
A PIPA, yes, a PIPA. Not only is it fun to say, but it actually means something. Automatic private IP addressing. It is essentially if your computer cannot communicate with your DHCP server, it is not being assigned an address, it automatically generates one for you so that you can troubleshoot on the network and try to figure out what's going on. So basically,
Can you
in a
say that
PIPA,
again? Can you say that again?
a PIPA, automatic private IP addressing. And basically, if you have what's called a dynamic IP, which means you are leased an IP or assigned an IP when you join a network, if you're not able to communicate with that server that's supposed to give you the IP addresses, the PIPA protocol will automatically generate one for you so that you can troubleshoot. You can communicate with network resources. So like if you're in the office, you could communicate with the printer. I could communicate with Rachel. You know, I could communicate inside the network. I just couldn't go outside the network. So if you ever have an issue where like I can print something, but I can't get to Google, it's likely that you weren't able to communicate with the DHCP server for some whatever reason. And then if you go look at your IP address, you have what is called an PIPA address, which always starts with 169.254.
It's like getting a an ID card when you lose yours.
Yeah.
So you can get access into the job, but you can't go to your desk. You know, you can't go to where you would usually work. You could just go to like the floor where everybody's allowed to work in. So everybody is like, you know, allowed to use the printer, the scanner and stuff like that, because that's where your computers are connected. But let's say you want to go and speak to somebody else across the network, you can't. You're not allowed to.
Gotcha.
So Kelly, who makes the order of these slides? You're confusing these people.
I believe that was my mentor who put that one in that way.
I gotta
So
talk
I'll
to
move
him,
him. I'll move him around. So The APIP address, it's essentially, it's an IP address that you assign yourself. Allows you to communicate with network resources, help you troubleshoot, things like that, which is nice. Instead of just saying you have 0000, you cannot communicate with anything. So this at least lets you to communicate. And this happens under what's called a dynamic IP, which we'll talk about here in a minute. And you're needing to be assigned an IP from a server. So basically they tell you, you show up, you're like, hi, my name is Kelly. I would like to communicate on the network. And the server just goes, yes, absolutely. Here's your address. Now you can talk to whoever you need to. So yes, Bubbacar.
Okay, if you want to get the IP address, do you configure it yourself? Like go to
No,
command
it's
prompt
automatic.
or-
That's it's in the name here.
But do you need to
Automatic
enable it?
private IP addressing. So if it can't communicate with the DHCP, it automatically gives you this IP.
Okay, so you don't have to do the IP config /all and then enable it and then.
No, you don't have to enable it. It automatically enables. But if you say like, look, I can talk to the printer and I can't talk to Google, and you go do the IP config to see what your IP address is, and you see 169.254, you know you have what's called an APIPA address, and it won't let you communicate outside the network. You can only communicate inside it.
Okay, cool, thank you. All right. Okay, so IP version 4, because remember we have version 4 and version 6. You have different types of communication. You have what is called a unicast, and a unicast is basically it's single host to single host. So if I want to send a message directly to Rachel, that is a unicast, me and her communicating, just the two of us. Then you have what's called a broadcast, which travels from a single source to all the destinations on the network in what is called the broadcast domain. And that's that address where you see that 255, 255, 255, 255. That means all bits are turned on, and it's sending it out to every address that it can reach. You can do what's called a directed broadcast. Like say, if I'm here in Jacksonville, but I want to reach out to all of y'all in KBCC in New York, I can use a 127. I can send a broadcast remotely from here to that network, and when it hits that network, it can broadcast out from there. So that is a directed broadcast. And then finally, you have a multicast, which has a single host to specific multiple destinations. So like if you have ever received like a web link to log into a meeting or something like that, like a town hall. Sometimes companies do stakeholder meetings or shareholder meetings where they're going to be talking about things they're going to be doing in the next quarter or whatever. Town halls will do it, if there's going to be city projects they're working on, and it'll be set up in a multicast format like this, where it's a single host broadcasting out to specific destinations. So unicast, broadcast, multicast. All right. Now, IP version 6, as we said before, that is 128 bits instead of 32. So it's a bit more IP addresses, and it's broken down into 8 fields or 8 groups instead of 4 groups, and there's 16 bits in every group versus 8 bits in every group for IP version 4. Now, in order to simplify things, there's 2 things that you can do, so you don't have to write everything out. So if you have consecutive groups of zeros, so you see right here we have 3 groups of 4 zeros, you can replace that with a double colon. So you see that right here. So these set of clusters can be replaced with a double colon, but you can only do that one time. Does anybody know why? Or want to guess why?
Because we cannot be sure how many zeros are either side. Like if they're in both sides, we cannot be sure
Excellent.
how many hexadecimal.
Excellent. So let me do a quick example here. Just put it here. So all right, so I have this address here. And then I rewrite it below. Like this, right? That would simplify it, right?
Mm-hmm.
Well, here's the problem. How do I tell the difference between, based off that,
Yeah, I see what you're saying.
do you get the difference here?
Mm-hmm.
So these are two completely different addresses that you can get from that exact same shortening.
Yeah.
So you can only do that one time in an address, the double colon. That's it.
Got it. Also,
Instead of doing the double colon, what you would do is just do, because the other thing we can do is eliminate leading zeros. So zeros that start in front of it. So like the 2 zeros in front of the CF, you can get rid of those. So you just type CF because we know the 2 that came before it were zeros. So that's the other way we do the shorthand. So if I was rewriting this another way, I would do this like, so I would just do a single 0 in each bracket because I can eliminate the other 3, because if there's just this one here, I know the other 3 are zeros.
mm-hmm.
You wouldn't do one more of those zeros because there's 3 sections of zeros between
Well,
DR.
sorry. This was
and
my
FE.
first IP right here.
Oh, okay. Oh,
This was the
got you.
alternate where I could either be this or this based off of the bottom address.
So
Honest-
why
I'm glad
can't
you
you
said that.
do the 2 double colons? What did you say before?
The 2 double colons replace this long group of zeros here.
So it's not just one section of
If you
zeros?
have just one section of zeros, they typically just put a 0 there, 1 0.
Okay, so
it's
it
more than one.
replaces- Okay,
So the more than one group of zeros.
so it could be 2, 3, or 4,
Yeah.
for example? Okay.
Correct. If there's just one, you would put just a 0 in there.
So how do you know how many Zero,
know there-
you would just fill it in.
Yeah, we know there are 8 sections. And right here I have 1, 2, 3, 4, 5. And I got the double colons, which means I'll have 2 sections of zeros in there.
Gotcha. Okay, so you just fill it in basically.
Basically, yeah.
Okay. That makes sense.
Ume.
Yeah. So with the zero, how do you know like how many colons you're gonna put? With 2 colon, how many zeros are there?
Well, that's what you got to fill in. So there's a total of 8 groups.
Let's say I have 12 zeros.
Well, if you had 12 zeros, so that would be, what was it, 4? That'd be 3 groups. So that'd be 1, 2, 3, right? Or no, that'd be, yeah, 3 groups of 4. So that'd be 12 zeros, and that's still a double colon, but we have 8 groups here, right? So a total of 8 is what we're supposed to have for an address. And if we have a double colon and we only have 5, that means we have 3 groups of 8 missing. Does that make sense?
Is there any other video that we can see or any other?
Yes. I have a power cert video where he breaks this down pretty well, and I'll give you guys that one as well.
All right.
Okay.
So basically, you don't use it twice, or else you have no idea how many zeros are on the other side if you do it twice.
Correct. If you use it twice, you have no idea how many are missing and where they should go.
Okay.
So you can only use it one time. The leading zero thing you can do every single time.
So let's say that CF in the example parts, since like, yep, they took the 2 zeros because there are going to be 4, 4 numbers or 4 whatever it is supposed to be there, but they only put 2 because 4 characters. So but they will only put the CF because it's assumed, they automatically assume that it's zeros, right? Since they're taking off. Okay.
So, but here's the other side of that. If it's CF00, you write out CF00 because it has to be the ones in the front.
Oh wow,
front,
really?
Yep.
So it's only because then you wouldn't know where they go, right?
Yeah, no, you're right. Yeah.
So it's only the leading zeros. So it's only the ones in the front. So any zeros that are mixed in have to stay mixed in.
So could you also do the double colon just for one set of 4 zeros?
Typically, they do a 0 in there when they do that for 1.
Yeah, I know, but is it allowed? Like, would that be readable? Normally,
somebody would
as that?
likely understand what you meant if you put that, but I don't know if the computer would route it properly.
Okay,
But
so
if you wrote it
computer
out,
wouldn't-
somebody would understand it.
So the computer wouldn't route it, and it normally
I-
does 0 for the one section.
I'll have to test it, but I don't think they would.
Okay, got you.
So it will never change, right, Kelly? It's always 8 sections with 4 characters. Okay,
Correct.
Perfect.
It's 8 groups of 4 characters, and it's in hexadecimal. So it could be 0 through F, correct?
That's it.
So what you need to be able to do for the A plus is identify a non-routable IP. And they're going to make it easy. They're going to throw like a G in there. If you see a G in there, it's not routable.
Mm-hmm.
They're going to put in 2 sets of double colons.
Mm-hmm.
Not routable. You need to be able to identify what is a non-valid IP version 6.
Cool.
Kelly.
Thanks.
Sorry, can you just do one example of you see how this the FEDC, right? And it 3 sets of 4 zeros. It has 12 zeros in front of it. And it has 2 more zeros before the CF.
Yeah. And then it eliminates those 2, and then you just have CF right here.
Right. You don't. All right. You don't represent those other zeros nowhere else.
No. And then the next one where they had 4 zeros right next to it, they just represented that as just a straight 0. Because they took out the 3 leading zeros and left just the single 0 in its place.
And then with your prior knowledge, you should know that you got to go fill these things in. And if it's 1 0, it should be 3 more zeros added and stuff like that.
Correct. Or if you see 2 or 1 character or 3 characters in there, you know that it's supposed to be 4.
So you know that it's supposed to have a 0 in front of it.
Oh,
So
gangster.
they can only
Yeah.
take away zeros, nothing else but
Correct.
zeros, right?
Only zeros. That's it.
Are we gonna have to unravel these and then like?
Yeah,
make
there's
back and forth.
Yes.
thing in Coursera. for
Yes.
Ah,
They call this
hear that.
IPv6 compression. And you need to be able to compress it and decompress it. And trust me when I say you don't want to type in all of this every time when you're putting an IP version 6 address in. So the compression really helps you as an IT professional. So yes, you want to be familiar with this. You want to be able to do this. It's once you do it a couple times, you're like, okay, yeah, it makes sense. I'm done. I got it.
Okay.
It's probably only going to take you about 4 or 5 times, and you'll get it. And it's, you know,
You broke
you're
my
good to go.
confidence for a second.
Kelly, I think one of the things that might be tripping everybody up is remembering that hexadecimal and binary are not mutually exclusive. Like they're
Yeah,
not
that is true.
different. So like you can use binary language with the 4 values here. So each
Yes.
of those zeros are just 0 because we know that there should be 4 bits of information between each of the sections there.
Correct.
So even if you're just going to compress it and you don't want to like say use colons, you could still just play it safe and just write out the zeros instead. You don't necessarily have to do the colons, but I'm guessing that Coursera is going to ask you to do.
Yes, Coursera is going to ask you to compress it, and then in the field, for your sanity, you're going to want to compress it, but you don't have to know. Because either a compressed or uncompressed format, as long as it's in there correctly, your computer can read it.
Okay, so for the CF example, for the 00 CF example, could it be 0 CFD and you would take that 10 out and just be colon CFD colon? So instead of taking the 2 zeros, it's on the 4th octet in the FEDC.
You talking about
So
this up here?
instead of being just 2, no, not the top one. So instead of it just CF, it would be you take the 10 out on the left and say put a letter in there,
Uh-huh.
and it would just be the 10 on the left. You would just omit that 10 and it would just be say DCF.
Yeah.
Okay. You know do you know what I'm asking?
Yeah, I
Kelly?
know what you're saying.
I'm getting lost what you're
always
asking.
drop-
So like it, go ahead.
No, he was just asking if instead of 00, if it was like a 0BCF, would you still take away the first 0? Like
Yes. Yes.
Yeah.
Absolutely.
That's what I was asking. Yeah.
Yes. No, that's
Okay.
correct.
Cool.
So is it starting to make a little more sense?
I'm glad
it makes
that
sense.
Ramon's
Yeah, I just
struggle.
want to like clarify like
I'm worried
the
about messing
certain
it up.
specifics and stuff and just
Of
get
course
it
you're
right.
gonna mess it up, George.
Yeah.
We're in this
I don't
class
want
for
to.
a reason, bro.
But yeah, you're gonna make
Why you do
mistakes.
that, bro?
We say that
Don't do
you're
that to
gonna
me,
make
bro.
mistakes. Get the mistakes in here. I'd rather you make it 50 times here and get it right on the test. So get comfortable with making mistakes. It's gonna happen.
Kelly,
Yo,
every time it's missing characters, zeros fill them up.
correct. That is absolutely 100% correct.
And only to make 4 characters, 8 sections.
Yes. So
If
8
it's missing
sections,
characters,
4 characters.
fill them in with zeros.
Correct. And the zeros can only go in front of it.
And the
So-
zeros can only go in front.
Yeah.
That's important. All right.
Kelly, could you
So-
use hexadecimal values as well? Like if you like you know how you can have, I think it's like 0001. You just turn that into 1. Would the computer still be able to route it correctly?
Yeah. Yeah,
Oh.
because it's what it is each one of these is like, so, you know,
It's
again,
decimal.
remember, it's 128 bits. So in all honesty, like this 1, 2, 3, 4, that's actually 16 bits.
Yeah.
So it's 0001 for 1, and then it's 0010 for 2, and then 000 or 0011 for 3, and then 0100 for 4. So it's
What I
all
was
4 of
saying
those
is,
put
like,
together.
Yeah, I was gonna say I think that's another thing that's why you don't want to have to like decompress this stuff. That's probably what's gonna make this lab annoying. I'm probably gonna have to buy a new monitor. You know, I'm gonna end up with a hole in it, man.
No, the lab only wants you to
but
compress.
don't decompress it all
Only
the way to the
compress
point
it?
of.
All right, thank God.
Yeah, you're not going to decompress it all the way to the point of binary. You're only decompressing it to the hexadecimal format. That's it.
All right. You see, yo, Ramon saved my monitor. Yo.
There you go. Amaya.
Do we need to have to know how to convert the spellings to binary?
No. Not for A+.
And even for Network Plus, why would they want you? Would they, Kelly? What is Network Plus like trying to do to us? They trying to rip us apart.
I mean, there's a lot of crossover. There's a lot of crossover for Network Plus, but they go a deeper dive on certain things.
I also didn't know that IPv6 used subnet masks. Not just,
no,
because I thought about it the same way that you would use it in IPv4. It's not the same.
Yeah, it's not. It's not. I mean, and it's not as critical in the IP version 6 version as it is in IP version 4. Okay. Because again, there's more addresses than there are on, grains of sand on the planet.
So everybody can be allowed to have IP address that's unique to them in that
I think every person on the planet could have something like 4 billion unique addresses to themselves.
Okay.
Is how many IP version 6 ones are out there.
I'm gonna start hoarding them.
There you go.
So what does that X6 the /64 mean?
That is a subnet. That is a subnet max or subnet mask for IP version 6. It's not as critical now, but that doesn't mean it won't be in the future.
So Donnie, you know how we would have the it would, what is it, 8, 16, and then 24.
24.
Yeah. Mm-hmm. So because we have 128 bits, it's just having each of those, filled up with 255. It's like times 64 because like each of them is 8.
Gotcha.
I've never seen that before. That scared me because I'm like, that's a lot of.
It again, not as critical, not as critical on the IP version 6, and not something you will typically be asked on the A+. So don't stress about that. All right, IP version 6, Babukar.
Kelly, like 1 or 2 slides back, you said the types of IPv6 address is unicast, multicast, and broadcast.
That was IP version 4.
That's the 4, okay.
Yeah, that was version 4.
The 6 is the unicast, multicast, and you need to go forward. I think.
Let's see, Pippa.
Nice forward.
That's forward. Okay.
Yeah.
Oh, there you go.
Yeah,
Unicast, broadcast, multicast, like IP version 4.
Okay. Oh, the version 6, is it going to be unicast, multicast, and anycast?
Yeah, it's anycast. Yeah, I think it's anycast, multicast,
and unicast.
Yeah, unicast. Okay. So there you go. So you have unicast, multicast, anycast. You just need to wait one more slide. And then you have 3 different types of unicast, which is global, link local. They love asking about the link local, and then unique local address.
Okay, thank you.
So link local is for
same types.
Yeah.
Okay, thanks.
So.
This is so much more than like I went through on 1001. It's like, it's scaring me because we didn't change that much stuff between.
Well, no, this is actually old 1001 stuff.
If 1001, then how come I didn't go over this? Like, I didn't go over it in depth like this.
It's a good question.
It was just like link local would be, basically talking to people that are.
Which book were you using? Mike Myers?
I was using Mike Myers, yeah.
Yeah.
Mike Myers, he does have a habit of breaking stuff down very simply. So
my problem with
maybe
him
that's
is like
why.
neither one of his tools are complete on their own. So you have to buy everything together the way he designs it.
Maybe I should have, because I was using the book for concepts that I couldn't understand.
Yeah.
In his lectures that I
Yeah.
was watching. So if there was a lecture that didn't go over something that was like, you know, pretty in depth, I would use the book to make
Yeah.
sure I understood it better.
That's why I always go back to Cybex, which is the book you guys got, because yes, it reads like stereo instructions, but it is a more complete understanding of the material.
Nah, this is scary. I gotta.
We'll get there.
I gotta fresh up my notes now.
Hey, you're doing fine. We'll get there. All right. So
Red Hot
we
Chili
know
Peppers.
you Red Hot Chili Peppers.
That's how I remember it.
Okay. So we know we have to have an IP address to be able to route and be able to talk to resources and communicate over the network. Well, how do we get that information? Well, there's two types of ways you can have obtain an IP address. There's what's called a dynamic IP and what's called a static IP. Now, static, it's entered manually. It's put in one time. It never changes. And if there's ever any problem with it, it's usually human error. Most organizations will not use a static IP method because it's harder to keep track of things once you start expanding. Like if you start growing rapidly and having tons of network devices, it becomes a lot more difficult to keep track of these things and maintain the IP numbers and all that stuff. So typically what will happen is they will use what is called a dynamic IP, which means it is leased to you or given to you for a period of time by what is called a DHCP server or dynamic host configuration protocol. Its purpose in life is you show up on a network and say, hey, I need an IP. Here's my information. And it goes, okay, here's your IP. Here's everything you need. Here's your subnet mask. Now you can communicate with the world. So it assigns those addresses and it basically says, hey, depending on the situation, you have this address for the next 7 days. After 7 days, if you come back to the network, I will have to assign you a new one. And then if your DHCP fails, if it's not handing out addresses, we fall back to the APIPA, which will allow us to start communicating with some of the network, other network hosts and see if we can troubleshoot and discover what the problem is. Am I the only one experiencing this problem? Is everybody else experiencing it? There's a fun question they love to ask where you go away for a long weekend, you come back, and half of the office cannot get on the internet, the other half can. And then come to find out the half that can get on the internet left their computers on over the weekend. And from there, you got to troubleshoot and find out what's going on. So how do we figure this out? We can go in, type in our IP config /all. If I have a Mac, what do I need to type in?
You throw it away
config.
and get a PC. Sorry.
IF config.
IF config. Adriel's apparently a Chevy person. So here we go.
Nah, we're built for tough around here.
There you go. Ford found on road dead. Oh.
Been in the family long enough, all right?
All right, so static. The IT professional puts it in manually. It never changes. This would only be for, small companies would do this, or maybe if you have a network resource that you never want to change. Can anybody think of something on the network that they would never want its address to change?
Sorry.
Server.
Servers. There you go.
Printer.
Servers. A printer. Anything else?
Anything that is there for stability. Say a managed switch. I'm not sure if managed switches have IP addresses though, because
No, because you automatically go into those.
Yeah, you go into
But
that.
NAS.
yeah, like yeah, NAS, network attached storage. Yes, you would want it to have like a static address. The gateway, so you can get out.
I thought routers just take that for its like on its own.
Yes,
So-
but you know you want that to be static so that it knows, right?
Oh,
So it's assigned a specific one on your network based on its range. It's usually the first IP. That's your router. It's your gateway. But again, we want it to be static, right? We don't want somebody else coming in and claiming to be the gateway, right?
wait, so can it
Yes,
change?
you can do that.
Can you change that? Like
You can set it up so that they try to come to you as the gateway rather than go to the actual gateway.
is that so? It's like
That's
okay.
insecurity.
Yeah. I was gonna say that's kind of like it's not the same thing as a proxy, but it's
No.
what
It's kind of like a
what I
man
was
in the
saying-
middle, I guess.
Yeah, I was saying if you had that on the network and it was there, somebody can't just come on the network and have it switch over to them, right?
No, there's obviously things you would need to override in order to make that
Yeah,
happen.
you have to like
but
plug out the router and plug in a new one, but even then it would get the same IP address.
yes, but there's certain software protocols that you can put in place to override stuff like that. So that's the thing. It's always an arms race, you know. So we have to be aware of some of this
I'm
stuff.
not feeling too confident right now.
You'll get there. You'll get there. Ah. All right. Here we go. So dynamic addressing. This is the most robust, easiest solution to implement if you have to hand out a lot of addresses. When it hands out information, what it's giving out, they need certain things in order to be able to communicate on the network, not just the IP address. So they need that subnet mask, right? So they send that out so the other protocols will be able, or the other hosts sending information will know which part is host, which part is network. So we have to send out a subnet mask. So the DHCP tells you what that is. It tells you your IP. It tells you your default gateway. How do I get out of here and communicate to the outside world? That is your default gateway. Then the next thing you need is what's called a DNS server. Does anybody remember from their readings what DNS stands for?
Domain name
system.
Domain name system. All right. Or server. There is an easy way to think of it. We carry a DNS server around with us all the time.
Google.
Your phone. So when you pick up the phone, you say call mom. It doesn't punch in mom, does it? No, it translates mom into an actual phone number.
Oh.
So when I say go to Google, I'm typing in www.google.com, and then the DNS will translate that and change it over to 8.8.8.8. So it translates a web address that you type in into an IP address to route it. That is the domain name server. Make sense? Am I getting crickets? Am I making it worse?
A little bit.
A little bit worse, or makes sense?
Making sense a little bit.
Okay, so yeah, so if I wanna go to, Amazon or whatever, the system doesn't route by names, it routes by IP addresses. So it needs to change that name to an IP address so that I can get to where I want to go. But it's easier for us to remember a place's name than it is to remember their phone numbers, right? So if I have 50 people in my Rolodex, it's easier for me to remember, call Rachel, call DW, versus having their phone numbers memorized in my mind.
Mm-hmm.
So I use a personal DNS server right here where I punch all that information in. So when I say call Rachel, it gives me Rachel's phone number and it goes ahead and calls her. So that's essentially what a DNS server does.
Cool.
Or if you only route them over the intranet or inside the company, you can use what's called a WINS server in place of a DNS server. Does this kind of make sense? DHCP gives you the IP addresses so that you can communicate. DNS server gives you the information you need to change a web address into an IP address so we know where we're going to communicate with these computers.
So this is mostly for remote protocols, I guess, like if you're trying to access a computer in a larger infrastructure?
No. What, you want the DNS?
Yeah.
You use one at home. Anytime you want to communicate with Google, Amazon, Spotify, any other remote system where you would have to use an application or a web address, anytime you put in a web address, like when you go to www.zoom.com, you're using a DNS server to translate that into an IP address so it knows who to talk to. Because we don't want to be putting in IP addresses every time we want to communicate with the system, right?
So you're only using that for larger, I guess, speaking to larger networks? Like if you're trying to access the Google servers, your DNS would...
Anytime you're trying to access any web resource outside of your system. So anytime you go to Chrome, Firefox, anytime you put in a FQDN or fully qualified domain name, you have to use a DNS server to translate that to an IP address. Okay. Computers only know the IPs.
Kelly, so is DNS is literally a translator of web address?
It's like a phone book
IP
for the
address?
internet. Yeah, that's what it does. Web address to IP address. It's a phone book for the internet. You look up the web address you want, here's the IP, and then it sends you there.
But that's what I meant, like, so that it routes you to the right server, I guess, so you can access that information that's located remotely somewhere. Like when you're typing in Google, you're going to somebody else's larger database to access it.
Yeah, Francis, do you have a better way to explain?
Try to make this, yeah, I'm trying to make this a little easier. So for the government, you're basically known by your social security number, but to people, regular people, think of them as overlords, you call them by their name. So I'm my social security number to the government, but you call me Francis. So think of it like that, if that makes sense.
It does.
Thanks, I got Francis. It. I was just trying to like visualize like what was actually happening. So that's what kind of lost me.
So you're calling out to the internet, I want to go to Google, and then the domain name server says, okay, what is Google in numbers? Oh, okay, it's .8.8.8. So if I were to say, I want to speak to George, and then I am the server trying to look at the database of social security numbers, I go, okay, this is George's social security number. Okay, this is who I'm looking to talk to.
Thank you.
It's just a translation.
Yeah, thank you so much, Francis.
You know, an old school phone book. You look up somebody's name and then it gives you their phone number. And that's basically what DNS is. It's kind of like a phone book for the internet.
Cool.
All right. So static addressing configuration in a PC, you go to your local area network. You can open up that network, click on properties right here. You see that? Then you'll open it up. You can scroll down to your Internet Protocol version 4, and then it'll open up a window here, you know, your next window, and it'll show you your protocol. It'll give you your IP address, your subnet mask, your default gateway, which is your router, and then your DNS server, and you can have a backup DNS server if you wish, because on occasion these things do go down. So you need these pieces of information to communicate over the internet: IP, subnet, gateway, DNS. That's the 4 keys to get onto the internet. I didn't say cheese.
What are the 4 things again? So sorry.
No problem. IP address. What is your address? Who am I? IP address. Subnet mask. I need to be able to distinguish in my address what is network, what is host. That's what we talked about earlier. Default gateway. That's the router on my network so that I can talk to the outside world. I have to go through that router and it will route my traffic from there. So I need to know how to get to it. And then finally, my DNS server. What's my phone book I'm going to be using to communicate with the greater world? Make sense?
Yeah, it makes
Got it.
sense. Just a lot of layers.
Yes.
Thank you, Rachel.
All right. What I'm going to do is I'm going to pause here. Continuing on here. So transitioning from your internal network or intranet into the internet out in the world. You need a gateway. This is what we were just talking about. This is your router. And then this makes forwarding decisions on whether something needs to stay internally in your network or if it needs to go beyond your network. And like we were talking about earlier, as we were running out of IP addresses, you have to get those private IP numbers that we use internally, and then we have public facing IPs. And all that stuff is changed around in the router with a protocol that's called network address translation. So as packets move in, they take off your internal IPs, they put external IPs on there, and they send it out. And then when it comes back, they take off the public IPs, put on the internal IPs, and then forward those packets through internally. So that's what it's doing. So it's network address translation. Yes, Nissim.
So what is the difference between the NIT and the DNS? DNS also translates.
Well,
IP
DNS,
addresses.
okay, well, so let's see here. So I have computer, of course my mouse is going to start acting up right at this moment. So my address is 192.168.15.1. So that's my address. And then I want to send something to Rachel. Let's say Rachel's IP address is 10.10.15.123. Come on. Now,
DNS is just domain names, no?
yeah, DNS is just domain name. We're talking about IPs here. So I got a router here. This is my computer. Rachel's computer. Her router. And then we got the internet at large. So I want to send a packet from here. And when it hits my router knows that this address cannot be routed over the open internet. So say I'm sending her an email. So I'm sending it out on port. What's an outbound email port?
21. No, 1010. 110.
Send
That's
mail
for
to people.
receiving also.
Send mail to people, which
Send mail to
is
people, 23, I think.
Top three. I'm at
25.
25. There we go. So I'm sending out an email on 25, but it's going to her. So that's the protocol I'm sending. And she's going to receive that on port 110, which is what?
Three.
Op 3. Okay. So this packet, as it comes into the router knows that it can't route that over the internet. So my external IP may be 185.27.131.82. So as my packet gets to the router changes it. So it takes my IP off and puts the router's external IP, which is this 185.27.131.82. So it puts that on my email message. That goes to Rachel's public IP, which may be something like 15.132.85.726.
Kelly, you're explaining
Yeah, that'd
NAT
be
right
simple.
now, right?
Huh?
You're explaining NAT right now, right?
Yes, NAT.
Okay.
And then when it hits her router will take this IP and say, okay, this message is an email. It is meant for Rachel. So what it will do is it will change this IP as it comes in into an internal one and then send it directly to her machine, which has that private IP address. So like Adriel was explaining before, we may live in two different buildings, but say both me and Rachel live at apartment 2C, but in two completely different buildings. So as it leaves my building, I'm going to change, it's going to be essentially the building address, not my apartment number. It'll just be the building address. And then it goes to her building. When it gets to the front desk, it sees that it's designated for Rachel. So it changes it to an internal and sends it up to room 2C. Does that make sense?
Yes.
So externally, you may
So-
see a PO box outside. So I'm sending a PO box 257, blah, 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 blah. And then when it hits that PO box, they see that and then they can route it directly to her after that. Does that make sense?
Yes, so there's no connection with DNS.
Yeah, there's no connection with DNS. DNS is just translating a web address name to an IP address. This is changing private IPs to public IPs. Because private IPs cannot route over the internet because there may be 10,000 people with the IP address 192.168.15.1.
Okay.
But once it goes public, but say there's 1,000 people that live in this building, we may all share this one public IP number. Because we're not all going to be talking at the same time, are we? So we're all sharing that one IP address, just firing things off, and and then the router is determining as stuff's coming back who it needs to go to. So it's making those forwarding decisions. And then when it comes in from them, they would send it out to where it needs to go. Yes, Nassim.
Yeah, I got it. Thanks.
Okay. Cynthia.
Sorry.
And then I
Me
will get.
too. Me too.
Go ahead, Cynthia. You got it? Okay. Who else?
Now I do. Yes. Thank you.
No
I was
problem.
just confirming that the 25 and the 110, those are port numbers, right? That you
Yes.
wrote there? Okay, cool.
So it's like I'm sending her an email, so I need to send it out, port 25. So I'm going send mail to people, and then that sends it to her email server, and then she pulls it down on 110.
Got it. Thank you. Just making sure I got the whole picture right.
Mm-hmm. Makes sense.
Sorry, Kelly. I'm sorry. Can you just talk through like from 192, 168, 15, all the way to 10, 10, maybe like just in like one sentence? I need to
Sure.
refresh.
Okay. So my internal address is 192.168.15.1. But I cannot send that over the internet. So when a packet comes from me into the router changes it into its public address. So what it's routing is outside of the network or outside of our network. And then it sends that packet. And if I want to communicate with Rachel, I have to send it to this IP right here, which is her public one. So the 15.32.85.276. So I would send it to her. And when it hits this IP, the router would look at it and go, okay, this is supposed to go to Rachel, and then forward it to her internal private IP, which is 10.10.15.123.
think I got it, Kelly. Cynthia, when you're thinking about like the way NAT works, think about it the way that we use actual addresses. Multiple places can have the same name and the same street, same number and stuff like that. But what we do are we give designations like zip codes. Zip codes then tell you where, even though it may share the same name, now you know it's a different place. So once you share the zip code, okay, instead of being in Brooklyn, we're in the Bronx. So it can't be the same, like Guardian Avenue, whatever. So now you're there. So now we're in the Bronx and we're in this zip code. What's the name of the street? Now we're on Guardian Avenue and we're doing the address. Okay, 2023 Guardian Avenue. Which apartment? Apartment 2C. That's how it's basically like that's how it's designated between each of them. So you wouldn't send somebody your apartment number along with where you live. You would probably just say, hey, you're going to send me something, send it to the post office, and the post office will send it to me. It's like that. That's basically how it is. So you share a public address, and then there's a private address inside of that public address.
Or you send it to the front desk of the building and then they would address it to the tenant.
Yeah, the person at the front desk would basically be your router and says, all right, so I know who this is going to. So that way you don't necessarily have to give somebody your address. You give somebody your address, you know, they're going to be able to find you. We don't want that.
So yeah, in essence, is it making a little more sense?
This is probably the only part of like CompTIA that can be explained in fun ways. Everything else is like, you got to try too hard.
All right.
Adriel, I didn't expect for you to go that simplified. You go to the Bronx. I really understand now.
Yeah.
Like it's like same addresses but different borough. I get it.
Yes.
Yeah.
Exactly that way. No problem.
And stupid trivia for the day. What's the most common street name in the country?
Huh?
I think
Main Street.
Main Street?
No, it's not Main Street. It's actually 2nd Street.
Okay.
2nd Street. You know what? I should have known that. It was on an episode of Big Bang Theory.
Yeah, it's 2nd Street because most first streets were renamed to Main Street. So
Yeah,
2nd
or
Street's actually the
something
most
else.
popular. So 2nd Street's the most common because a lot of first streets were renamed to Main Street. So useless trivia for the day. All right. So how do we use the IP addresses on the internet? And so we get back to FQDN, which is fully qualified domain name. Yes, please remember that. FQDN, fully qualified domain name. It identifies a computer and network which it belongs, and it allows the domain names to be used like www.google.com instead of typing in 8.8.8.8. So it's simpler for us to remember, you know, what to type in rather than remembering, you know, a bunch of random numbers to get to where we need to go. That's where the DNS server comes in. It resolves host names into IP addresses and vice versa. And the database not only contains the fully qualified domain names and corresponding IPs, but also the record types and pointers to other servers that can resolve IP addresses for other names. So if we're going to like a .uk address or .co or something like that, if we're going to another country's domain, we would be rerouted once it sees that qualifier, send us over to a domain, a DNS server over there, and then that would translate it to the IP that we need. So it either gives you the address you need, or it points you in the direction to get the address you need. So one of those two things, based off of the information it has from you. My mouse was not wanting to play today.
You get the hand back, and it's like your computer is like, no, we liked it the way it was prior.
Basically, yeah. So as soon as I get my hand back, my computer doesn't work. All right, so binary, we're coming back to this. This is a bit of a review. It is a numbering system with two options. You either have 0 or 1, which represents off or on. You have 1 bit, 4 bits make a
nibble.
Okay, 8 bits make a
byte.
Byte. What's another term we can use to say, for byte?
Octet.
Octet. It's 8.
Let's go, bro.
So,
Listen,
so 8 bits make an octet or a byte. With 8 bits, you can create 256 combinations, 0 to 255, because 0 takes up a spot. Here is the binary decimal, conversion table right here. I would practice writing this down. It's just a quick and easy way to do it. If you have to deal with binary, you can write it down real quick, and it gives you a quick way to calculate it. So you can translate binary into numbers or numbers back into binary. If you remember, we had a little bit of practice of this when we were doing IT fundamentals. Some of you are still having nightmares about it. All right, so we all comfortable with binary translation? We've done it, a couple weeks ago. We reviewed it again. Do we need to go over this again? No? Closed mouths don't get fed. All right.
One more time.
One more time. All right. So give me a random number there, Galen. Between 1 and 255.
247.
247. All right. So we draw out our fancy little binary chart like this. Would you say 247?
Correct, sir.
247. All right, here we go. 247. All right, let me write that. Let me write that a little higher. I'm gonna steal my son's mouse here in a second if this thing keeps acting up. All right. 247. All right. Here, give me 2 seconds. I'm gonna go steal a mouse real quick. Make my life a lot easier.
When Rachel takes over.
Where's Rachel?
Rachel got us.
Rachel to the rescue.
Rachel, did you take the Network Plus?
I've had that experience.
Oh man. I don't like how you said that. I was so confident and now I'm not. Maybe it's not for me. Who knows?
You can be confident. You can be confident.
All right, I'm back. All right, so 247. So does 128, can you take 127 or 128 out of 247?
Yes, you can.
Yes, you can. So what do we need to do right here?
1.
Put a 1, yeah. Put a 1 there, right. So we put a 1 there because we're going to use that number. All right, so 128. What's 247 minus 128?
119.
Boom. 119. So can I take 64 from 119?
Yes.
All right, what do I need to do?
1.
Put a 1 here. So what's 119 minus 64?
55.
55. Awesome. All right. Can you take 32 from 55?
Yep. Yep.
All right. What do I need to do?
So 1 again.
1. All right. So 32. What is 55 minus 32?
23.
23. All right. Can I take 16 from 23?
Yep.
All right. What do I do?
Another 1.
1. So 23 minus 16 is what?
7.
7. Can I take 8 from 7?
No.
All right. What do I need to do?
0.
0. All right. Can I take 4 from 7?
Yes.
All right. What do I need to do?
1.
1. What's 7 minus 4?
3.
3. Can I take 2 from 3?
Yep.
All right. What do I need to do?
Another 1.
1. 3 minus 2 equals
1.
1. And 1 from 1, what do I do?
Also 1, right?
Also 1. All right, there we go. So our binary representation for 247 is 1, 1, 1, 1, 0, 1, 1, 1. Basically, you need to activate all the numbers to add up to the number you're trying to get in binary. Does that make sense, Caitlin?
I got it.
Excellent.
Thank you, guys.
Nope, no problem. All right, so that's binary. We just did the binary conversion, so we're good to go on this one. Flippy bit. Anybody start a Twitch channel yet?
Nope.
No. Anybody even try it? You tried it, Madison? How'd it go?
Terrible.
It takes a while to get used to, that's for sure. But it's not bad practice. All right. So now, over the TCP/IP, there's 2 primary protocols that almost all ports fall under. And that is TCP or UDP. So you have TCP, which is Transmission Control Protocol. And you have UDP, which is User Datagram Protocol. So remember we talked about earlier, we were saying that TCP was 2 computers having a conversation where I'm sending packets to Rachel. Her system is going, all right, you know, I'm supposed to have 20 packets here. I'm getting 1 of 20, 2 of 20, 3 of 20, 5 of 20, 7 of 20, and then go and so on and so on. And she's like, okay, well, I'm missing 2 packets. I need you to resend. So it's verifying on a regular basis that the stuff I'm supposed to be sending is being received on the other end to make sure that she's getting everything she needs of the data I'm sending. This is typically web browsers, email, stuff like that. Now, UDP doesn't do all that fancy stuff. It doesn't sit there and ask if you received it or any of that stuff. It literally just fires off and hopes. So all the stuff is just sent at you. It's best effort. It's whatever you can get onto and hold on to. So you ever been watching a TV show or a sports event or something like that, and you see it start to pixelate? You start getting those artifacts on the screen where, you know, like the screen's not so very clear and it gets all blocky and all that stuff. That's the internet missing packets. Now, there is no point for them to go back in time to 2 minutes ago when you were watching the game and fill in that data that was missed, right? It just moves on with its life. It tries to clean up what's going on as it's continually being thrown at you. It's best effort. It's whatever you can catch or hold on to. You make the request and it just starts firing away. So typically this is something you would see in broadcast television. You would see this in voice over IP, anything where it's more speed oriented and you want to try to make sure you're getting the best possible communication or connection. TCP is where data integrity is important. If I'm being sent a spreadsheet, I need to be sure that I got all of that spreadsheet. So that's where it breaks it down into packets. And then it says, you know, hey, I'm sending 20 packets. Here's the 20 packets. Did you receive the 20 packets? Yes, I've received all 20 packets. Or no, I'm missing packets 3, 7, and 15. Please resend. And then it would resend again and say, okay, here's those 3 packets. Did you receive them? Yes, I did. So there's an actual conversation that's happening under TCP where UDP is just like, hey, I want to watch this movie. And it's like, okay, here. And it just throws it all at you and you got to catch it.
Reliable and unreliable.
Sorry, so basically the UDP would be like the version that is just throwing whatever it needs to at the wall to see what sticks. Like it's just basically giving you the whole thing at one time. Am I getting that correctly?
Kind of. I mean, it's just firing everything off at you and you're sitting there trying to receive what you can. So it's like I said, it's something, it's like streaming service where, you know, you're not going to go back 5 minutes ago in the video and try to fill in those blanks that you missed where the screen got a little pixelated. You want to just keep watching the show, you know, or if you're on a phone call and the phone call gets a little, you know, like it starts to cut out a little bit, you're not going to want them to go back and fill in those packets from a couple seconds ago. You just want the connection to be cleared up going forward, right? So that's basically the difference between your TCP and your UDP. Yes, Babukar.
TCP is reliable and UDP is unreliable.
That's not necessarily the best term to use. One is connection oriented, meaning it's maintaining a conversation. So there's a two-way conversation happening, and the other one is just a one-way conversation, best effort, do what you can.
So the TCP is more like the three-way handshake.
Yes, exactly. TCP is the three-way handshake.
Okay.
So yes, that is a part of TCP.
Thank you.
That's where you're like, hey, I want to have a conversation. It's like, okay, let's have a conversation. And beginning conversation, you know, and then the two systems are linked together. They're now able to really start talking.
So why is it called three-way?
Well, what it is it's basically you want, you know, you're letting it know, like you say, I want to synchronize. So it says a sync. And then the computer will respond with an ACK or an acknowledgement. And then the first computer will be like synchronize, acknowledged, and then the conversation would happen. So it's three pieces of communication that happen really fast to initiate the conversation. So it's sync, ACK, sync, ACK. So you're synchronize, acknowledging, and then acknowledging the synchronization. So that's three pieces, and they call it a three-way handshake.
So UDP would be a single handshake, like we're just sending you receiving.
No, UDP is just, you know, like you just ask for something and it just throws everything it can at you.
Okay, so it only goes up to 3, from Coursera. Like, I remember that from.
Well, there's a three-way to initiate, and then there's a four. I think there's a four-way
the last acknowledgement.
And there's a four-way to cut off communication.
Oh yeah, the close. That's right. I forgot about that.
Yeah. So there's a four-way close, and there's a three-way initiation. So
that's the fin, right? Finish.
Correct.
F-I-N.
Yeah, it's like fin, ack, fin-ack, or something like. Yeah, but yeah, it's a four-way handshake to end communication.
So, now it's making sense. I couldn't get that before.
Yeah. All right. So network sockets. So when we're communicating over the network, we're using things called APIs or application programming interfaces. And then this is how we would connect over a network to specific protocols. This is not to be confused with what's called a physical socket, like your Ethernet port on the back. These are communication ports. And like we said, you have some physical ports on the back, and then you have APIs that are, I think there's 65,000 on your computer, 65,000 ports. We only need to know about a dozen or so for the A+, but understand that depending on the type of communication you're going to be having, you need to communicate with specific ports. So if I wanted to send an email to somebody, here's a good example of it. It says I'm going to send it to, the IP address would be 30.60.30.5, and then I could put a colon and then add the port number so that it lets it know that this is an email going out. See, a lot of this stuff is happening behind the scenes for you, but you can physically make it happen on the top. Or if I wanted to communicate with a web server, which is the HTTP protocol, I could use 136.60.30.5, and then I would use the colon to indicate what port I want to communicate after that. So that lets it know as the packet is going through, when it hits their network, I want to communicate with your web server. I don't want to communicate, like if I'm going to Google, they have a whole bunch of different services. They got Google Sheets, they got Google Drive, they got the search engine, they got email, all that stuff. How does it know I want to communicate with? If I put 80 on there, it goes, oh, okay, you need my web server. Okay, here's Google search engine. Boom, right there. So the protocol lets the receiving machine know how you wish to talk to them or what services you want to use. Does this make sense? So right here, all they've done is they have the IP address, which is this right here. And then they put a colon right there. And then they said, I want to communicate on port 25, which is what?
Email.
What specifically is the port number?
SMTP.
Here we go. It's SMTP. So that's our email protocol. All right. All right. So let's get into some protocols and well-known port numbers. So,
Excuse me, Kelly.
yes.
What's API?
API?
Yes.
It's kind of like the overarching term for the protocols and the programming requests that we're doing. Like if I want to do email or web server, whatever, that is application programming interface. So that's the overarching term for the ports we're going to be using. So instead of physical ports, which are where we would plug in our monitor and our network cable and all that stuff, we would have our API ports or our software ports to communicate over specific protocols.
Okay, thank you.
Mm-hmm. All right, so we talked about our TCP and the various protocols that we use. So both your TCP and your UDP will utilize these port numbers. Some port numbers fall under UDP, some fall under TCP. They really don't get into the woods in this. In A+, this is more of a network plus thing, but just understanding the difference between TCP and UDP will help you out a lot. All right, so in the next few slides, we're going to talk about some common protocols you need to kind of be aware of. I would take a screenshot of this. We do have a mnemonic to help you remember most of them. There's a couple more we'll add on after this, just to kind of, because they've added a few that we need to know, but these are some of the big ones. These fall under what is called your well-known port categories. So you have your FTP, which is your file transfer protocol. It's like if you want to send files between two computers, you can utilize this. Those operate under ports 20 and 21. So file transfer protocol does what it says it's going to do, transfers files, ports 20 and 21. Please, I cannot stress enough, get a screenshot of this page. Your book gets into a lot of these as well. You have secure shell, which allows you to pass login information to a remote control or remote computer and control that computer over the network. And it adds a level of encryption to your communication. So secure shell, port number 22. Telnet allows you to control a computer remotely. So essentially allows you to go in and start remotely using that computer. However, everything sent over Telnet is in what's called plain text. So there's no encryption. It doesn't hide what's going on. It literally, if anybody is watching on the line, they can see everything you're doing. Sign-ins, passwords, all that fun stuff. So it is in the insecure protocol. You usually add on secure shell or something with it in order to utilize it. But it allows you to control remote computers, port 23, and transmits in clear text or plain text so anybody can read it. SMTP, we should all be familiar with now. That's sending mail to people. So simple mail transfer protocol, that is outbound mail from my computer. And then we just talked about it today, domain name system or DNS. So domain name system DNS, that is port 53. But the book goes over a lot of this as well. This is the last batch for here. And again, we'll get into, there's a couple more we'll add on probably tomorrow just so that you can have a full roster. Here you have port 80, which is HTTP, that is Hypertext Transfer Protocol. That is the way the web works. So it communicates with your web servers and how a web and client will interact. It is insecure. So this also is kind of in plain text. There's no encryption involved. It literally is open. So anything that's sent over for HTTP can be visible by anybody watching on the line. In order to secure it, we would add encryption to it, and then we get up to HTTPS, which is Hypertext Transfer Protocol Secure, and this encrypts the data before it is sent and processed. You ever been on the internet and you look up at your URL, you see a little padlock? They have an open padlock and a closed padlock. When it's open, you're communicating on HTTP port 80. When it's closed, so that it's a secure website, you're communicating on port 443, HTTPS. So it's nice we have that quick little visual we can see now so we know if it's secure or not. Before we would put in a credit card, I wouldn't rely upon that as being the end all be all, but for the most part, lets you know you're operating on a secure communication. Backing it back up real quick, POP3 and IMAP we talked about earlier last week. So you have your POP, which is Post Office Protocol, which is how you would pull down email messages from the server. So that's your receiving messages. Then you have IMAP 143, Internet Message Access Protocol, which allows you to pull down messages as well and store and forward capability. So the messages are still stored on the server versus POP3 where you're pulling them down and you have them on your machine at that point. And then the last two are RDP, which is Remote Desktop Protocol, which is a way for you to kind of go in and remote into somebody's computer and do work on it if you need to. This is typically a Windows protocol, and that is port 3389. And lastly, our app. Yes.
Sorry. Is that what Telnet does, but more secure?
Yeah, but I mean, Telnet is something you would use a lot of times to link into servers and things like that as well remotely. You wouldn't typically use an RDP for that. RDP is like more what we would use like tech support style. So, but yeah, similar, just with some slight differences.
Thanks.
And then you have the Apple filing protocol, which is a proprietary resource sharing for Apple, obviously. This one isn't being used much now, but they still like us to know it for some reason. Do we have a mnemonic to help us remember these things? We do, but we'll get to it here in just a little bit. So Other protocols, but we'll get to some of the port numbers on these here in a little bit. DHCP, Dynamic Host Configuration Protocol. That is your network protocol. What do we use DHCP for? Why is that important to us?
To assign IP addresses.
IP addresses. So when I connect to a network, what does it give me? So it gives me an IP. Anything else?
MAC address.
No, it doesn't give you a MAC address. Thankfully, the manufacturer guy gave us that. So not a MAC address.
You said when you sign on to what? Say it again.
When I first connect to a network, I reach out to see if there's a DHCP server, and I say, hey, I need to talk to the internet. It gives me 4 things. First thing it gives me is the IP address. What else does it give me?
Subnet mask.
Subnet mask.
Default gateway.
Default gateway.
The DNS server.
And the DNS server. There you go. So IP address, subnet mask, default gateway, and DNS server. Those are the 4 things the DHCP server gives to us when we first connect to a network.
Can you repeat the 4 things it gives us again?
Sure. It gives us an IP address. It gives us a subnet mask. It gives us a default gateway. And then it gives us a DNS server. Yes, Madison.
Back to what we were talking about before with the, what is it called? The static. What is it? The static.
Static versus dynamic. Yes.
Yes. So essentially, are we acting as the DHCP when we're putting in the information manually?
Yes.
Okay. Thank you.
Mm-hmm. We're negating the need for a DHCP when we put in everything manually yourself. So yes. All right. So DNS, talked about that. Why is the DNS important to our lives?
Oh, it translates web addresses to its IP address.
There we go. And what do we want to refer to web addresses as?
Domain.
Fully qualified domain name, FQDN. Fully qualified domain name.
Oh.
So good job. Good job. So fully qualified domain name. All right. Next, we have the LDAP, which is port 389. Which is the lightweight directory access protocol. If you remember directory, this gets you most of the way there. It's basically, if I'm communicating with a very large business, I would get there and be like, oh man, I need to talk to HR. So I would go to the LDAP, and the LDAP is kind of like the internal directory for that network. And it would tell me, yeah, HR is on this network. So it is the lightweight directory access protocol. It's kind of like the phone book for your internal network, letting them know where they need to go to communicate with what. It might be a list of emails for people who work there or whatnot, but it's just kind of like a little bit of like a small phone book for your network. So LDAP, port 389. All right. Next, we have SNMP, which is Simple Network Management Protocol. So this is how you would kind of manage some of your devices on your network, like some security devices, logs, routers, switches, you would use SNMP to communicate with those devices. Simple Network Management Protocol. This is port 161. Now, I want you to pay special attention to this one because they really do love putting this in as one of the answer choices for email. So instead of SMTP, they're going to put SNMP, and it trips up a lot of people. But always remember, send mail to people. And then it'll make it easier to distinguish this one, but they will always put those in there together because people tend to get them reversed or confused. So SNMP. SMB, don't need to know the port to this one, server message block. It's used for reading and writing files and to request services from your server programs. And then, like we said on the previous page, secure shell or port number 22, used to pass, or yeah, 23, excuse me, used to pass along login information encrypted to a remote computer and to control that computer over the network if need be. Then you have SFTP finally, which is the secure version of file transfer protocol. You can send files, but at least they're encrypted. FTP sends it and it's not encrypted or secure. And I think you may need to know SFTP. And that is port 22. Wait, SFTP. So it's using the secure shell on top of FTP, so it's port 22. All right. Questions so far? These are the only two from here that you really need to know port numbers for on top of what we've been talking about.
And do you want to add the LDAP-S, LDAP secure port 636?
That would be a network plus. That would be network plus, but so we did talk about DNS. One more I may add would be DHCP, which is 68. I think we mentioned that one. So DHCP is port 68. So I do think they bring that one up later. So yeah, each protocol has a specific purpose and a specific way for them to be able to communicate.
So basically the one that deals with that handles the email, that will be the IMAP. Am I understanding that correctly? Because each of them has their own.
Well, if I'm sending me email out, I'm using port 25, which is SMTP. If I'm pulling emails down from the server so that I can read them, there's two ways I can do that, and that is IMAP or POP3. Those are the two protocols I can use.
Thank you.
Mm-hmm. All right. So let me see here. Oh, here's the 7-layer OSI that I was telling you all about. You can take a quick shot of this. So this makes a little bit of sense. They don't use the DoD model, but just real quick. Google's model has the physical, data, network, and transport. And then what it does is it takes these three protocols here and combines them together to make the application layer. The 7-layer is what they would call like a, it's more of a clinical or educational model versus a practical model in the real world. You would use probably a 5-layer, which is the Google one. So theirs is more practical, where this is more academic. And It's a good one to have a picture of because it tells you what protocols are operating on each of these layers. So TCP, UDP, that's all happening on layer 4. Layer 3 is your, IP version 6, ICMP, which we have not talked about yet, which is basically a ping, and your IPsec, MPLS, your ARP requests. And then on your layer 2s, you got your 802.11s usually, point-to-point protocols, which we haven't talked about, fiber optics, MAC addresses, and then you get down to the physical link. That's your cables and connectors, hubs, stuff like that. So good one just to have a quick picture of, just to kind of be able to break down the OSI model. You should not receive a lot of questions on this, but it may make the Google stuff make more sense, Coursera. So questions on that? Or is it just a please let it end moment? So, all right, public addresses class A, you don't need to know this. It's just, it's kind of an FYI thing if you wish, but it'll be in your student paste if you like. VLANs, I like to hold off talking about VLANs until we get into servers and stuff like that. So we will revisit this a little bit and talk a little bit more about VLANs. And this is when we're talking about virtual switches and stuff like that, where we can set up virtual local area networks to communicate. So like you can take a big switch and break it up into small groups. And so they would be set up as like virtual local networks. But again, I like to talk about this after we talk about network servers. So they just kind of show it here where you basically, like they have 3 virtual local area networks on a single switch. And you just isolate them on their own networks using the managed switch, where you basically can tell it what to do. That's all this is. But again, we'll talk about this at a later time. All right. VPN. We've already talked about it a little bit, and we will talk about it again during security. So I'll give you guys a pass on this one for today, for right now. And here is the mnemonic for the well-known ports, for the majority of the ports you need to know. This one helped me remember it. This was one of those things that I wrote down on the blackboard every single day before, like when I came in first thing in the morning and when I came back from lunch. This was one of those things that I wrote down every time. RAID arrays, 7 steps for laser printing, port numbers. These are things that I wrote down a couple times a day until I could do it flawlessly. So the mnemonic for this: for safe technicians, simple deeds help put amateur hackers at rest. These are aligned in ascending order. So if you can't remember the port number, like if I forget what DNS is, I know it falls between SMTP and HTTP. So it's somewhere between 25 and 80. And then that might trigger my memory as to what the actual port number is. So it puts them in order and helps you remember the ones you need to know. So I encourage you to take a screenshot of this one.
This one is cool.
Yeah, so please get a shot of that. I'll give you a couple seconds. We all good?
Not yet.
Not yet? Let me know when you're ready.
Kelly, what's the minimum port numbers we need to memorize for the
I think
AirPlug?
it's somewhere, it's like, I think it's like between 12 to 15 ports.
Babukar, put it in
So
the
all of
Slack
these
channel.
and then a couple extras.
It's like 16, 17.
16, 17, okay.
Okay.
Thank you.
Something around there.
It's most of them are it's like they all fall into a certain category though.
Okay.
All right. Here we go. You made it. Deep breath. We should now be able to explain purpose and role TCP/IP, the internet and private network. We should understand a little bit as to what network address translation is. I'm going to be sending out a video on this as well. It kind of breaks down the class A, class B, all that fun stuff down into a little bit more manageable chunks. So it'll help. And then I'm going to get the Mike Myers video that kind of shows how the network packets move through the protocols and stuff, and what each of these protocols are doing. So we'll watch that. It's probably about a 5-10 minute video. And then we should also be able to explain some of the characteristics and properties of TCP/IP, some common port numbers like port 80 HTTP, port 20 and 21's file transfer protocol, 22 secure shell, 23 telnet. But we'll work with these for a little bit and they'll start to become second nature. They become a lot easier to remember when you're working with these ports every day as a technician. And when all else fails, you can always Google what the heck is port, what is the LDAP port? And it will tell you. So, there is always a fail safe. But yeah, over time, you become more comfortable working with them on a regular basis. All right.